Hello guys, welcome back to my YouTube channel. So today we are going to solve day 12 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2070. Most beautiful item for each query. Okay, so in this problem you are given a 2D integer array items where items of I is representing two things. Okay, one is price and the beauty, okay, of an item. Okay, you are also given a zero indexed integer array queries. For each queries you want to determine the maximum beauty of an element. Okay, for each query you want to determine the maximum beauty of an item whose price is less than or equal to that particular query. Okay, if no such item exists, then the answer to this query is 0. We have to return an array answer of the same length as queries, where answer of j is the answer to the jth query. Okay, so let's understand this with example number 1. These are the items given to us, and this is nothing but price, and this is nothing but the beauty. Okay, and now here see, this is queries array given to us, and here the length of this queries array is 6. Okay, and in the output you see that we are also getting the same output of same size, right? So we have to turn an array answer of the same length as queries. Okay, that is simple meaning, that's what I'm saying here. Okay, so now what we need to do here? Okay, so see, what is my first query? First query is 1. Okay, so here let's see the items in which price is less than or equal to 1. So only this item, right? For this item only we have price which is less than equal to 1. Okay, there is no other item whose price is less than equal to 1. Okay, so for this item, what is the beauty? Beauty is 2. Okay, so here I'm returning beauty. Okay, beauty value 2. Okay, so now next, let's see next query. Next query is 2. Okay, so now let's see the items whose price is less than equal to 2. So one is this item, one is this item. Okay, so we have two items. Okay, and out of these two items whose beauty is maximum, this item's beauty is maximum 4. Okay, so here we are returning 4. Okay, now let's see the next item. Next query, so query is 3. So number of items whose price is less than equal to 3. So these 3 and this one. Okay, total 4. Okay, so we have these many items, and out of these items the max value of beauty is 5. Okay, so we are returning 5 here. Okay, all right, now let's see next item. 4. Okay, so number of items whose price is less than equal to 4. Okay, same set, same, or only these 4. Okay, and for these 4 max beauty is 5, so that is why I'm returning 5. Okay, so now let's see this next 5. Okay, so number of items whose price is less than equal to 5. Okay, all the items will come, and out of all these items whose beauty is max, this beauty is max, right? So we are returning 6, and same before this 6, we are returning 6. Okay, that's it, that's what we need to do. Okay, and this is example number 1. Okay, let's me see if there are any other inputs given to us. Okay, so now see this example number 2. Okay, so here we have this queries 1. Okay, so we have this item, this item. Okay, all these items. Okay, and out of all these items, this 4 is max, right? Beauty. So price of every item is equal to 1, so we choose the item with the maximum beauty, 4. Okay, that's it. Here 5, but this item price itself is 10 na? So here the items whose price is less than equal to 5, none. Okay, so we are returning 0. No item has a price less than or equal to 5, so no item can be chosen. Okay, so simple thing we need to do: for a particular query we need to find the items whose price is less than equal to that particular query price. Okay, and then from all these items we have to find the max value of beauty. That's what we need to do. Okay, so now how I'm going to solve this problem? So first thing what I will going to do, I'm just going to sort these items based on their price. Okay, if I sort them based on their price, I will directly get the result, right? So I don't need to search like this and then this. Okay, I can directly implement the binary search. Okay, so what I'm going to do here, I'm going to sort them based on their prices. Okay, so first 1 2 will come. Okay, then after that 2 4 will come. 2 4 will come. Okay, and after that 3 2 will come. Okay, and after that 3 5 will come. Okay, and then after that here 5 6 will come, right? 5 6 will come. Okay, so I have sorted them based on their prices. Okay, this first index is nothing but price, and second index is of beauty. Okay, so this is, let's say this is my index 0, index 1, index 2, index 3, index 4. Okay, and inside this is 0 index and this is 1 index. Okay, 0 index and 1 index. Okay, inside this is 0 index and this is 1 index. 0 index, 1 index. Okay, this is just for representation. Okay, don't worry about this, just showing that this is 0 and 1. So at 1 we have beauty, at 0 we have price. Okay, so now what we need to do? Okay, so here 4 6, what we are doing, we are just gathering here 4 6. We see that all the items are coming 4 6. Okay, all the items are included whose price is less than equal to 6. Okay, then out of these elements we are finding the max now, right? So here what I'm going to do directly here, see 1 2, here 1 item 1 and 2. Okay, I will keep the same price. Okay, this price and beauty. Okay, so next is 2 4 2, and here I will keep 4 only. Okay, 4 2 is the max here, here 4 is the max beauty. Okay, max beauty I'm finding. So here 2 is the max, here 4 is max. Now here instead of 3 and here instead of 2 I'm going to write 4. Why I'm writing 4? Tell me why I'm writing 4 here. Okay, so simple answer, here I'm writing 4. So here 4, if you are searching for this item query 3. Okay, so what are the items that are included? So these are the items that are included: 1 2 3 2 2 4 and 3 5. Okay, all these items are included. Then out of these you are finding the max beauty. Okay, so max beauty, if let's say if this one has beauty of 10, then you will write this 10 only, right? If this price one has max beauty 10, then you will write the max beauty only na. So it doesn't matter the beauty of this one if this is not the max beauty. Okay, we all are only taking care of the max beauty. Okay, and we know that for 3 simply means that we are searching for less than equal to 3. Okay, so all the items are coming. So if this instead of this here if 10 was there, so we have to use 10 only, right? So this 3, for this 3 2 doesn't matter. For this 2 we can, instead of it we can directly write 10. Okay, because 10 is the thing that we need to return, right, in the end. So here in this question for 3, what you are returning? You are returning 5. Okay, you are returning 5. Okay, so that's what we need to see here. Okay, so only we are dealing with the max beauty. Okay, max beauty, so that is why 2 4, and here I move to the 3 price, but here I will keep the max beauty only that I have till now, that I have got till now. Here 3, so for 3 5. Okay, so let's use max beauty here. Then for this 5 this 6 I have to use. Okay, max beauty. So see, max beauty is always going to be updated. Okay, going to increase here. Okay, so this is the next thing that I have to do. Okay, you are clear why I'm writing max beauty here instead of just 2? Because for smaller prices we may have max beauty. Okay, so we have to use that beauty only, right? So this is what we are doing, right? We have to find the maximum beauty of an item whose price is less than equal to that queries of j. That's it, right? So that's why I'm doing this. Now in this I have to implement the binary search. Okay, once I get this I have to implement the binary search. So binary search is very simple, right? First left I'm going to say 0. Okay, this is 0 index, this is 1 index, 2 index, 3 index, 4 index. Okay, my right is equal to 4. Then I will find the mid. Okay, mid is going to 0 plus 4 divided by 2, so I will get a mid as 2. Okay, my first query here it's 1. Okay, it's 1, so I will show you for 1. Okay, so first query is 1. Okay, this is nothing but price. So what I'm searching, I am searching for prices which are less than or equal to 1. Okay, this is what I'm searching, less than equal to 1. All right, so here I did this mid, but I get this price 3. Okay, I am here. Now I know that this price is greater than 1, not less than equal to 1. Okay, so what I'm going to do, I'm going to update my right as mid minus 1. Okay, so this is mid, so my r right is going to be updated as mid minus 1 in this case. So mid minus 1, simple binary search I'm doing now. So here right is 1. Okay, so left is already at 0. Okay, I didn't update left. Okay, so again find mid. So mid is left is 0 and right is 1 divided by 2. 1 divided by 2, we get mid as 0. Okay, this is what we get. Okay, mid as 0. Okay, so now after that what we need to do, mid is 0, so I reach here. Okay, mid is equal to 0. Okay, now I see here for this mid 0, the price is 1. Okay, and my condition is valid. Okay, my price is less than should be less than equal to 1, and this condition is valid here. Okay, for this mid. So now in this case what I need to do here, I have to update my mid beauty. Okay, my max beauty as math dot max of max beauty, and the this beauty. Okay, 2. Okay, I have updated this. So let's say max beauty is 2 here. Okay, now here one more thing I have to check now. I have to do L is equal to mid plus 1. Okay, L is equal to mid plus 1. So if I did this, so mid is 0 1. Okay, L is becomes 1 and my right is 1 only. Okay, so my L is 1, L is 1, and my right is also 1 right now. Okay, so now here see my left is still less than equal to r, so inside this I will again do my mid. So L plus r divided by 2, I will get 1. Okay, mid 1. So at mid 1 I will see this one. Okay, so for this we know that this condition is not satisfied, so my r is going to be decremented. Okay, so r is going to be here this value. Okay, so now my L is 1 and my r is 0. Okay, r is 0. So my in this case my left is greater than r, so simply I have to return from there, and the max beauty that I have got here 2. Okay, so that's what we need to do. Okay, so now there is one more case. Okay, let's say, okay, this will be confusing little bit right now, but when I'm going to write the code you will understand. Okay, simple binary search code I'm going to use. Okay, so let's say my query is 3. Okay, so now for this q is equal to 3, how I'm getting 5? This is your question, right? So now what you guys going to do, my put my L as 0. Okay, left is equal to 0, right is equal to 4, and you will get mid as 2, and at 2 you will see that this is satisfied, so your max beauty is going to be 4, right? Now but 4 is not output, right? You are getting max beauty as 4, but 4 is not output. For 3 5 is going to be output, so that is why I am incrementing the left now. So I have incremented left to 1. Okay, so now again left is 1 and right is 4, so again do this. So my mid is going to be left plus right divided by 2. Okay, so L is 1, r is 4. Okay, so we will get 5 divided by 2. 5 divided by 2, again you are getting 2 only. Okay, so again you check again mid is 4. Okay, again increment the left. Okay, so we have to only stop when my L becomes greater than r. Okay, until then we have don't have to stop. Okay, so here now my L is going to be 2 and my right is already at 4. Now my mid is going to become 3. Okay, now at 3 I see that this condition is also satisfied. This is 3, so my max beauty will become 5. Okay, max beauty 5. Okay, now again my L is going to increment, so L is going to become now 3. Okay, and r is still 4. R is still 4. 3 plus 4, 7. 7 divided by 2, again I will get 3. So 3, again this case is satisfied. Now again L is incremented. L becomes 4, R becomes 4. 4 plus 4 divided by 2 is equal to 4. Okay, at 4 I see this condition is not satisfied. Okay, if this condition is not satisfied, then what we are doing, we are decrementing my right as mid minus 1. Okay, so here uh, mid minus 1. Okay, so my right is going to become 3 and L is going to become 4. Okay, now L becomes greater than 4, I have to stop, so that is why I got 5 here. Okay, simple thing. Okay, simple thing, whatever I explained, just go over the code. Okay, after this, and you guys will be understood. Okay, so now let's write the code for this one. It's very simple. Okay, so here what you need to do, int answer is equal to new int queries dot length. Okay, and then we have to sort and store max beauty. So first let's sort them. So arrays dot sort, we have to sort what? We have to sort items. Okay, and we have to sort them based on their price. Okay, so here let's say we have two items A and B, and how I'm sorting? I'm sorting them based on their price, and their price is at 0 index. Okay, so that's why I've explained previously why I'm writing 0 1. Okay, so that's a simple thing. All right, now after that, max. Okay, let's take the max from the for the starting item. So items and max beauty we are considering, so that is present at index 1. Okay, so for first element, first item at 1 index we have that. Okay, beauty. Now I'm just going to iterate over all the elements. Int I is equal to 0, I is less than items dot length, and here I'm just going to increment I, and after that we have to just answer the ith query. So I'm just going to update my answer of I. Oh sorry, so here we have to take the max value. Now we have to keep adding the max values instead of the original beauty. We have to add the max beauty. Okay, so that's why first take the value of max of the max that we have already got in the past, or that particular uh, items beauty. Okay, so one sorry, here I, and here you have to write 1. Code is very simple. Okay, simple thing. And here inside this you have to update the, for that particular item you have to update the beauty as max beauty always. So that is why we have to write here like this. Okay, I1, it should be I, and here it should be 1. Okay, and this should be max. Okay, that's the simple reason. So we are done with this step, this one. Okay, we are done with this step. So 2 4, then we are writing 3 4 here. Okay, that's the simple thing we are doing here. That's it. Okay, now what we need to do after that, we have to iterate over all the queries that are given to us. Okay, all these queries. So what we are going to do, we are going to run one loop for int I is equal to 0, I is less than queries dot length I plus plus, and inside this we have to update my answer of I. Okay, so answer of I, so here let's say I'm calling this helper method. Okay, binary search. Okay, binary search, and in this what I'm doing, I'm passing the all the items that I have, and that particular query price that I'm passing. Okay, target price. So here I'm just going to write queries, okay, of I. Okay, so I'm expecting this to give me a valid answer. Okay, for each item. Okay, for each query. So here in the end I'm just going to return answer. That's it. So here let's write this binary search. So simple thing, private, let me decrement the site here, spelling mistake, private int binary search int items int target price. Okay, and inside this now same thing, I'm going to write take L as 0, take R as items dot length, and here minus 1. Okay, and then initially max beauty for each item is, let's take as 0. Okay, max beauty is equal to 0. Then we have to run one while loop, and this should only be executed for my left less than equal to R, otherwise don't execute it. Okay, and inside this we have to calculate the mid. How we are going to calculate? L plus R divided by 2. Okay, and here once this is done, then here I'm just going to check the beauty of that one. Okay, if items of price, sorry, price we have to check now. If items of mid 0, okay, at 0 index we have that. So if it is greater than target price, okay, that simply means that it's not covering that what we need. Okay, so in that case I told you we have to decrement the R as mid minus 1. All right, and in the else part we have to just we have found one price, and we have to keep moving to the right to check for the max beauty. Okay, so first let's update the max beauty as math dot max of max beauty, and here items mid, and here 1. Okay, for beauty we need beauty only, right? And here we have to do L is equal to mid plus 1. Okay, so now if my L becomes greater than R, then we come out of this, and here I'm just simply going to return max beauty. Okay, so this helper method binary search is going to return the max beauty for each query. Okay, max beauty, that's it. Now let's run the code and see if there are any code issues. So all the test cases has been accepted. Wonderful. Now let's submit it. So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.